Hi and welcome to this new demo lesson. Here we will see how to use SQL to perform some ad hoc queries on top of the streaming data. So here you are seeing the second part of the demo, which is the structured streaming, but I will start with KSQL, which is Kafka, which is a SQL layer on top of Apache Kafka. So I will start again the Docker Compose. The Docker Compose contains my data generator that simulates some user activity on a website, of course Apache Kafka Broker and KSQL DB servers. So I will start them again. Okay, it's currently starting. The first step is to open the KSQL console. And I will create the first part of the demo, which is the stream, the visits stream. Okay, maybe I will just keep this create command. Okay, stream created, and stream is one of two main concepts of KSQL. The second one is a table. So to define a stream is an unbounded and immutable sequence of events that is used to create a table which is, as you know already, a view of the stream, or it can also be a view of another table. And unlike the stream, the table is mutable. So after the first step, I will now create the first table for the visit stream. The language, as you can see, is very similar to SQL. Here we are creating a table as select, so with CTS, and the table does a sample grouping for page visits. Okay, the table is created, and I will start the query that will accumulate the visits for each table and emit the results to my console. So as you can see, the results are changing, continuously changing, but the point here is, as I have been saying in the theory lesson, the values are read only from the point of starting the query. They are not read from scratch, as you can configure them for an ad hoc querying on top of the batch layer. Here we really start the real-time view of the data. We are computing the visits from this created query with ID message. So that was for the quite basic query with groupings, and now we will see something much more complicated, much more challenging, using windows. So here my query uses a window tumbling of 10 seconds, and later I'm running the query to emit the same changes, and you can see that we have this information again with the count. And another important point is that all this data is written to another Apache Kafka topic that you can later query with a consumer. So here you can see that I'm reading the page visits counter, and you can see that we only have one value in the JSON, simply because the category here is kind of primary key of the table. So yeah, it's the page name. And that's the reason why it's not included in the values, because it's already present as a key, so there is no need to repeat it. Okay, that was for the KSQL. I will just close everything to avoid... Oh, sorry, I shouldn't have closed this Docker containers, so I will restart them again. Okay. And let's see how to use this SQL from Apache Spark structured streaming. So there are two ways for doing that. The first way is with a native data source that you use when you use only the select expressions or eventually the filters with some SQL support. And it's quite simple. You don't have anything to do except maybe writing these expressions with strings with SQL rather than the programmatic API. So I will start the code for this part, and you should see some things going on in the console regarding the processed data. That, as you can see, will only filter and show the category pages. Okay, you can see that it's correctly prints the category pages for the current visit, at least, and there is also an execution plan for that. So that was relatively easy. The second part lets you do more. But if you want to do more with this temporary view solution, you will need to register your input data source as this temporary view. So under the hood, it does nothing. It's just a kind of logical operation that helps Apache Spark reference your query to this table. And this table is nothing more. It's still the Apache Kafka data source. There is no any table creation on the local file system or the distributed file system or on the object storage. It's just an alias. And I will show you that with the grouping query and the execution plan that will be printed just after a few runs. And as you can see, we are correctly grouping the visits. And now the funny part, the part of the execution plan. So to show you the mechanism, so that's the plan that Apache Spark parsed and converted to an execution tree. And you can see that we have our view node. But this view node, as you can see here, is just a kind of subquery alias. There is nothing like replacement for this streaming data source v2 relation by the view. Streaming v2 relation is still there even after optimizing the logical plan. So generally there is only a kind of soft reference, so an alias, as I've been saying before, that helps Apache Spark to connect your query to the data source for which you use this alias. And that's all for this lesson. You can see that there are two ways, at least for Apache Kafka, to perform an ad-hoc querying. There is also other frameworks, other solutions also available with the cloud services, but here we stay simple, we stay focused on this part, and it's good to know that the ad hoc querying is not only possible on the data at rest, on the data from the batch layer, it's also possible for the data in motion. Thanks for watching and see you in the next lesson.